We already know how to solve a system of equations graphically. We already know how to solve by substitution. But when you look at this question, 3m minus 6n equals 0 and 3m plus 3n equals negative 7, why might this not be the best type of system to solve by substitution?
Because there's no one by itself.
Right. There's no variable that doesn't have a coefficient. Now this you could solve fairly easily by substitution if you isolated the m in the first equation, but it's not obvious right away that there's one that's easy to isolate without dealing with fractions. And so this is the type of question that we want a different method for. And the method we're going to use is the elimination method. So we're going to solve this by elimination. And here's how it works. Step 1 is multiply one or both equations by constants to make opposite coefficients on one variable. What does opposite coefficients mean? What does opposite mean when we're talking about numbers? Positive, negative, right? Opposite numbers would be like positive 2 and negative 2. Or positive 5 and negative 5. Or in this case, maybe negative 6 and positive 6 might be what I'm looking for. We need to multiply one or both equations by something so that they have opposite coefficients. So right now the m's have a 3 and a 9. We would want to either change those into 9 and negative 9 maybe by multiplying. Or here we have negative 6 and 3 on the ends. What could we change both of those into? Negative 6 and positive 6 would be the opposite. So it doesn't really matter in this one whether we choose the m's or the n's, but I think I'll choose the n's because they already have opposite signs. So what I'm going to do is leave the first equation as is. And the second equation, I need to multiply it by something so that 3n will change into a 6n. 2. Multiply the whole thing by 2. So when I do that, I'm going to put it down below here. 9 times 2, that's 18m. And plus 6n equals negative 14. Now we have what we wanted, opposite coefficients on the ends. One has a negative 6 and one has a positive 6. And then we want to add the equations together. So I'm just going to add like this. 3m plus 18m, that's 21m. Negative 6n plus 6n, 0. That's the elimination part. These are eliminated. The n's are gone altogether. And then 0 plus negative 14, negative 14. Once we add them together, as long as we did that, got opposite coefficients, then one variable is going to be eliminated. And now we're left with this equation that's pretty easy to solve. And that's what it says to do, is solve the new equation. So to isolate the m, we'll divide by both sides by 21. We're going to have a fraction here, but that's okay. M equals negative 14 over 21, which can reduce to, negative 2 over 3. There's the m value. And it's always going to be easy to solve once you've added them together. It's pretty much just going to almost always be just a variable with a coefficient equals a number. So you'll just divide by whatever that coefficient is. And then solve for the second variable. This part is sometimes a little bit more difficult. But you can choose either of the two original equations to solve for n. We already know what m is. So I'll take the first one. 3m, so that means 3 times negative 2/3, minus 6n equals 0. So I just took this equation at the top, and replace the m with what m is equal to. So 3m minus 6n equals 0. And we'll solve for n. So 3 times negative 2/3, that's negative 2. And then I'll add 2 to both sides. Negative 6n equals 2. Divide by negative 6. And we get n equals negative 1/3. Here's another one that we're going to solve by elimination. This one is not really a good candidate for using substitution, because there's no variable that's easy to isolate. No matter what you do here, if you isolate one of the variables, you're going to end up with fractions that you have to deal with right off the bat, which we don't necessarily want. So that's why we're going to use elimination on this one. So we need to look at the coefficients on the variables. The x's have a 3 and 5. By multiplying them by some numbers, what could we change them both into? That would be the same. We could change them both into 15s, or we could change the coefficients on the y's into 12s, or 24s, but we like to pick the smallest if we can. Which one do you want to work with?
15.
You want to change them to 15s? Okay. So if we're going to eliminate the x's, what can we multiply the first equation by? 5. Yeah, that'll change that into 15. That'll change this into 15x minus 20y equals 35. Now we have to multiply the second equation by something as well this time, because right now it has a 5x. And what do I actually want in front of the x?
A negative.
A negative 15, right. So what can I multiply 5 by to make a negative 15?
Negative 3.
Negative 3. So when we do that multiplying by negative 3, this becomes negative 15x plus 18y equals negative 24. Does that seem right to you? So then we add them together. That's the next step. So once we've done that multiplying, add them together. 15x plus negative 15x. The x's eliminate. Add the y's. Negative 20y plus 18y is negative 2y. And 35 plus negative 24, or 35 minus 24, 11. And then divide by negative 2, so we end up with y equals negative 11 over 2, or you could call that negative 5.5. I'm going to leave it as 11 over 2. Now we just have to find the other variable. And we can use either of the original equations to do that. I'll just take the first one. 3x minus 4 times y, but y is a negative 11 over 2, equals 7. Negative 4 times negative 11 over 2 plus 22. Subtract 22, and we get 3x equals negative 15. When you subtract 22 from both sides, divide by 3, and we'll end up with x equals negative 5. We can check our answers. We use the first equation to find the negative 5. Let's test it in the second equation. So I'll go 5 times x, which is negative 5, minus 6 times y, which is negative 11 over 2, and that should equal 8, and it does. So if you fill those numbers in for x and y, simplify, it should give you what you have on the other side. And then you know that you've done it correctly.